Hopefully she'll come in late. Alright, so did you guys generate your numbers for the sheet?
Now, I wasn't sure if we were supposed to do this together or...
I just went ahead and did it, and then I think after, let's see, in part D, question 7, that's when we kind of we compare our sample to each other.
Okay, so we were all supposed to do it differently?
Yeah. So we should have gotten different samples.
I thought we were... Okay.
There we go. I think we found Samantha. There we go. Wait. Oh, yeah. Okay. Oh, you're logged in as Tyler Newton. Hello?
Hello?
Hey.
We found
You're logged in
you.
as Tyler. That's probably why you weren't getting it.
I am so frustrated. I'm looking at my Samantha Newton Google Plus account as we speak.
Okay.
I don't know why I'm logged in as two things.
I don't know. That's weird. Okay.
Can I make a suggestion for future events?
Yeah, what's that?
I've done this with other classes, and we create an event before the night of, and people just join, and there's never been any problems.
Okay.
I mean, I'm happy to set up the event. Can we try that so it's not a battle every single time?
The problem was we couldn't video it that way, right?
Well, you can still,
Tyler?
let me take a look at it. I think you can still create one, and it'll just be for later. So let me create one right now, and then so later, the 9th at 8 p.m. And then just make sure. So
When I've done it in the past, we did not have to record it, so I don't actually do the recording side, but we never had problems with people joining. And it seems like, whether it's me or someone else, we have a problem with someone every time we meet.
yeah, it's just that we've sent it to the wrong Hangout address, or the wrong account.
I don't know why I'm logged in as Tyler, because I'm logged in as me as well. But whatever.
That's really weird. Let me take care
Oh,
of this.
are you logged in Google under somebody else? Or no?
My computer is logged in under my email, which is what I was waiting under, and my husband's. Apparently it connected to my husband's when I put the link in instead of mine.
Okay. That's weird.
Next time I will have all other emails logged out, and maybe that will eliminate that problem. But Anyway, sorry. You can just get going, I guess.
Okay.
Creating it right now. Just that way, like, while you guys are all here, you can check and make sure that you got the invite.
Okay.
Oh, for the next one?
Yeah. So, October 9th, 8 p.m. Does that work? Thursday?
Yep.
8, yeah, it's good.
Okay. Okay, I just shared it, so let's see if you guys go ahead and check and see if you got it.
October 9th. Yeah, I got it.
Cool.
Does it come in as an email or through Google Plus?
It's on Google Plus is where I see it. It says upcoming events, and then it has October 9th down, group meeting 7.
Is that just on the home page?
Yeah, I have it on plus.google.com.
Yeah, and then at the left you'll
On
have,
the home page of Google Plus?
there's a drop-down menu on the left, and you're going to click on that and go down to events.
Oh, okay.
Gosh, this is so annoying.
Yeah, I got it. We're good.
Cool.
Do you send it to mine or my husband's? I guess now I like.
I sent it to yours. I don't know if you'll be able to log out. Let me see if
It's so weird. Okay, well I can look at this at the end so everyone else doesn't have to wait for me. I don't. All my past events from previous classes.
all right, check your chat for the video. I just sent it there. Click on it and see what happens.
Oh, it's there too. I see it there too.
Okay. So that way, if you're logged in under yours or Tyler's, hopefully it'll work. So you have the link either way. Did that work? Oh, that was weird.
No. I'll have my husband help me. I don't know. I'm.
All right. Well, let's get started then. Did you guys generate your numbers for this, or pick out your 5?
Yeah, I got
That's
5
not mine.
picked out.
Okay. Cool. So, my sample mean. Actually, let's just put in our mean, the numbers that we got. So that was my mean right there on chat. You look at it.
Oh, on chat? Okay.
Yeah. It's 46,480.
This is mine. I picked all the big numbers. They're bigger.
Oh yeah.
you not see it, Samantha?
If you're waiting for me, just keep going.
You can text. You just text your me. You can do it that way too.
Or you can
I'm
just
trying
say
to
it.
find my stuff, so just keep going.
Oh, okay.
Yes.
Where are we putting our means at again? Just send this thing over here.
Yeah, there should be a group chat to the right.
I did.
Oh, yeah.
Or you can just say them and then I'll type them in.
So mine's 57,780. I'm on my phone, so I don't really know where the chat is on my phone.
You said 50,780?
Yeah, 57,780.
Oh, okay.
Not be that high because there's no value.
Wow,
that
holy
high.
cow.
There's no values that high though. Or there's one. Well, I guess there's two.
So you picked like the two highest ones. Which numbers did you draw?
Are you talking to me?
Yeah.
Yeah.
That's really high.
They're kind of close together, and they're like, I got just 11. I just did 11, 13, 15. So because my numbers were 45, 300, 57, 800, 52, 800. They weren't that random. I can do more of a random draw if that would make it better, probably.
Well, no, that's fine because I mean this is a good illustrative practice. So you drew number 11, 13, 15, and what other two?
I did 11 through 16, just a row,
Oh, okay.
just right out of the middle.
So
11 through 16 is 6 numbers though. You want to do 12 through 16 or 11 through 15?
Oh yeah, that's probably why it's off. So, why you do it?
yeah, so putting in the ones that you did, 11 through 15, I got 48,920.
Yeah, I got 48,720. 48,720 is what I got now. That brought it down a lot.
Yeah, I did. So, and then Samantha just posted hers. So, what's pretty cool is that they're all pretty close. Because the mean is about, it looks like it's about 4650. And both of ours are within about so I kind of drew on the curve where each of ours are. Let's see. So those lines right there. So that's where each of our means landed.
All pretty close.
Yeah.
Yeah,
Pretty good mean.
that's cool. All right. So I guess all of our samples aren't unusual. They're pretty standard. All right, should we move on to question 8?
Yes.
Sounds good.
All right, the GMAT is used as an admission criterion. MBA programs scores are normally distributed with a mean of 529 and a standard deviation of 13. Consider simple random sample where n equals 10 students taking the GMAT. What is the shape of the distribution of the sample means for all such samples?
It's normal, right? Is that what it
Yeah.
means?
Yeah. Because all the samples together are going to be normal as well. Question B, how do you know that the distribution of the sample mean has this shape?
Just because it's normally distributed? Or...
Yeah.
Just
And
like
go ahead.
population is distributed, right?
Yeah. And I think it's also because n is greater than 5. So if you have more than 5 samples in a normally distributed population, then
Yeah.
your sample will be normally distributed too. Question C, what is the mean of the sampling distribution of sample mean scores for all such samples?
Isn't it just around the 529?
Yeah, it's the same mean as what's listed, the 529, I think.
That's right.
Is that what you guys did?
And that's what the key says too. Question D, what is the standard deviation of the sampling distribution of the sample mean scores for all such samples?
So that's
Here. Go ahead.
113 over the square root.
Third of 10.
Yeah,
So 30.
'cause it's the
Go ahead.
because it's the standard deviation of the population divided by the square root of the number of samples. So
Yeah.
35.7. Cool. That's it for that. Any questions?
Looks good to me.
Cool. Shall we start the quiz?
Sounds good.
Remember to answer questions 1 and 2. All right, is everyone there?
I'm here.
Yep. So since it's 5, or so number 3, since the sample is 5, does that make it normal? Is that what we were saying?
That it was only if the parent population was normal.
The parent,
If it's
right.
But since it's... Oh, okay, yeah.
yeah, so it's skewed right. So you need, I think, 30 sound to be normal. Is that right?
Oh, because of the skew.
Yeah.
Where are you getting the 30 from?
It's-
It was from the reading. I don't know if I can
That
pull
like
it now.
chapter you had to read for the prep.
Yeah. So, yeah, for number 3, I'm going to put skewed right.
Okay, yeah, it says in the, it's
I'm trying
greater
to find it in the reading real quick, but
It's under 5, review key concepts. But it's in there too.
Thank you.
oh, okay, sounds good. Thank you.
Yep. So number 4, so n is 100. So it should be normal.
Yeah, it's pretty high.
And number 5 is normal again, because it's normal and it's greater than 100, right?
Yep.
So if it's skewed, it has to be greater than 30.
Yes.
Yeah, that's the general rule of thumb.
Okay, yeah.
Because they gave an example, if you're looking at lottery winnings, you have to do like millions and billions in order to get it to be
'Cause there's-
normal.
Yeah.
It's
Okay.
just, it's so extreme, but... Alright, when would the distribution of means be normally distributed? I think it's all of them except for when it's right skewed and the sample size is small.
Because it needs to be larger. But
Yeah.
Data drawn from a population that is right and the sample size is small.
yeah, sounds good to me.
Alright, number 7. What do you guys think about 7?
I think it's if the sample size is large, the shape of the sampling distribution of the sample mean will be approximately normal.
Yeah.
Yeah, I think
Yeah, because it describes what happens to the shape of distribution. So yeah.
Yeah. That's kind of like word for word out of the book, too.
Well, is it? I thought it was if the parent population is normally distributed, then the sample will follow a normal distribution.
In the book under central limit theorem, it says, you observed in the simulations that if the sample size is large, the random variable sample mean will be approximately normally distributed.
Okay.
then I printed out the definitions too. And it says if the sample size is significantly large, then the random variable will be approximately normally distributed. So that's
Okay. All right. Yeah, we'll go with that then. All right. 8 and 9.
But it says the shape of. Okay.
Yeah.
I know, that's
Yeah.
the only thing I'm wondering. It says the shape of the sampling. Are you back to 7, Cheryl?
Yeah.
Yeah, I was just wondering. I think that's what it is, but it does say shape. So I'm not.
let me,
I'm not 100% sure, although that's my best guess.
yeah, so here, I'm looking at one of the keys. So it says the central limit theorem states that if the sample size is large, the sample mean will be approximately normally distributed. That's it.
It doesn't say about the shape.
Well,
But that's the same thing, kind of, isn't it?
sample, yeah, if the sample mean is approximately normally distributed, that describes the shape, that it's a bell curve.
Yeah.
Okay.
And I can't. Yeah, I still think it's that one. Yeah.
Okay.
Just because the other ones don't make sense to me, at least. But.
Yep. Cool. We good?
Yep.
Yeah.
All right. Number 8, X random variable, mean 10, population standard deviation is 6, suppose the sample size 36 is drawn. So what does the mean of the distribution of sample means?
What was the formula for this again?
For the mean,
Yeah.
it's the population mean. It's the
Oh, okay,
same.
yeah. Sweet.
Yeah.
Easier than I thought.
Yeah,
Well, it's just the population, so it's
it's 10. Yeah.
Yeah, it's just the mu.
And then, what is the standard deviation of the distribution of sample means? This one's the one with the formula.
This one is 36 over the square root of. No.
No, it's
Other way around.
6 over.
yeah,
6 over
6 over the square root of 36.
36.
Yeah, which is 6.
Which is 6 over 6, which equals 1, right?
Yeah.
Yep. That's right.
Then
Alright. 10 record. Go ahead.
It's just normal then, right? If we have greater than 30.
Yeah.
So 10 is normal, and then
And I had a hard time with these two theorems because they sound a lot alike.
Yeah, they do.
they're pretty close. to each
So,
other.
the central limit theorem has to do with the shape of the distribution. The law of large numbers has to do with the standard deviation. So, the law of large numbers basically says that the more samples you have, the smaller that the sample standard deviation will be.
Okay. So would this be the central?
the central limit theorem, right? Because it has to do with the shape.
Yeah.
It is the central limit theorem.
Yep.
Yep.
Cool. All right, I'm submitting it.
Perfect.
Awesome. Let me get the link. Oops. Awesome. All right. You're welcome.
Thank you.
All right. Let me know if you have any problems. If you don't get that invite.
I'm gonna log out of all of the emails and then just log into the one.
Yeah.
So
Okay.
Thursday at 8 then?
Yep.
Sounds good. See you guys then.
All right. Take care.
Thank you. Bye.